Hi everyone, Haley here with Menlo Coaching, and I want to talk to you a little bit about problem solving using two of my all-time favorite problem solving examples. One of the most interesting things about problem solving often comes down to these questions' simplicity. They look a whole lot like the regular math questions you've seen and completed your entire life. And for many students, even very high performers, that can mean that the tendency is to want to rush to put pen to paper and crunch the numbers and do the math. But remember, this is a critical thinking test first, which means that very often, even on very high-level questions, the challenge has way more to do with how we're breaking down and identifying what the question stem's really asking us, seeing what that easiest path to the answer looks like, and identifying what tools we can leverage along the way. Let me show you what I mean. Now, if we take a look at this first example, whether you've seen this example before, or maybe you want to pause the video and take a look at it now, where do you end up? Does your math end up looking a little something like this? For many students, it does. And it's because that despite the fact that they put together some otherwise pretty correct math, they missed out on the bigger picture and failed to leverage the details of what the question was asking them to solve for. And often that comes down to a single simple word, in this case, only. So if we're reading through this question stem, we can pretty quickly see that all of the 100 pages need to be initially typed, giving us that 100 times 5. But we then needed to leverage the number of pages that went through that first set of revisions, which isn't 40. It's the 40 that were revised only once, plus the additional 10 that then needed another set of revisions, giving us 50 times 3, or 150. And if we pair that with our other terms, we'll get to our correct answer of 680. So the challenge of this question didn't have to do with how quickly we can break down and multiply numbers like 100 times 5. The challenge came into play because we needed to make sure that we were reading carefully, leveraging all the assets in front of us, and answering the question that's being asked. Let's take a look at one more example. Now, in this next example, again, whether you want to pause the video and take a look at it now, or perhaps you've seen the question before, there can be a pretty serious tendency to want to rush to set up the algebra. And you could, and if you did, your math would probably look a little something like this. And this isn't by any means impossible math. It's very doable math, but it's a little lengthy, it's a little number crunchy, it involves some non-integer values, and particularly, depending on whether or not you identified, that if the question was asking us how many years it would take before the number of type A planes was less than 50% of the fleet, it was really asking us how long it would take for the number of B airplanes to exceed the number of A airplanes. Well, this question could have become pretty time-consuming, pretty calculative, and that means that for many students it could become pretty error-prone. So let's think about leveraging everything that we have in front of us, because one of the really valuable things that jumps out to me to leverage here is our answer options. They feature clean, easy to work with integer values, which means we could leverage them directly and backsolve. Now, backsolving isn't by any means an alternative to knowing the algebra or knowing the math, but sometimes it's just the easiest path forward. So if we start with a middle term, let's say, in this case, answer option C. Well, after 8 years, there would be 60 minus 8 times 3, or 36 type A planes, and 8 times 4, 32 type B planes, which means we're not there just yet. We need the number of type B planes to exceed the number of type A planes. But that also tells me that while I can rule out answer option C, I also need more years to have passed. So I'm going to jump down to answer option D and give that one a try. And if I plug in 9, well, 60 minus 9 times 3, well, that's going to give me 33. And if I compare that to 9 times 4, or 36, I found my answer. The number of type B planes now exceeds my number of type A planes. And again, I didn't get there by having to do a whole lot of math, but instead by leveraging everything in front of me and ensuring that I was taking the easiest path to the answer.